so let's talk about population growth. Okay, so right now I'm not going to talk about technological growth. I'll first talk about population growth, and then I'm going to just gradually move on to technological growth. Okay, uh, so um, so let us say now we have constant population growth. Okay, we can also have some other type of model where population growth is not growing at a constant rate. You can have variants. Okay, you can have lots of variants, but let's assume that population growth is constant. Okay, and so LT is, so basically LT plus 1 is 1 plus n times LT. Okay, so what that means is, it's no longer a single consumer economy, but there are lots of consumers and all of them are identical. So you can imagine that kind of scenario. Okay, and so now what I'm going to do is I'm going to assume constant returns to scale technology. Okay, so I'll briefly tell you why we are going to assume CRS in this scenario. uh, you know be- so I'll talk about that. Okay, uh, so uh, so suppose this is how the labor changes over time. Okay, and K0 is your initial capital. Okay, and again the production function is y equals flk. Okay, so the only difference between this model and the earlier model is that now we have this constant rate at which the population is growing in every period. Okay, rest everything is the same. You have some exogenously given savings rate, you have some exogenously given depreciation rate. Okay, is this fine? Okay, and we'll be assuming CRS. Okay, so FLK is constant returns to scale. Okay. Okay. Now, one reason why we don't want to use, for example, IRS, okay, is because I mean, let's go back to the previous case first. Where there was no population growth. Okay. So we don't want to use IRS because of the fact that there is no decentralized solution to that problem. Okay, in reality it's decentralization, which is the reality. It's not the centralized model, it's a decentralized model. Firm is maximizing profit, consumers are taking their own decision, and then demand equals supply. That's basically what the reality is. With increasing returns to scale, the solution to the profit maximization problem doesn't exist. That is one reason why uh, obviously that kind of model will not give you the proper result. Okay, I mean the real result. Okay, another thing is that IRS increasing returns to scale is also not a very kind of realistic assumption. Okay, in the sense that when your labor is going to double, your output more than doubles, and this happens every time. Or labor capital doubles, then your output more than doubles. This happens every time, no matter what level of labor and capital you're operating at. This is kind of an unrealistic assumption on production function. Okay, so there are several reasons why we don't use IRS. Okay, so that's gone. I agree, we have reasons to use decreasing returns to scale technology, and that is something that we can still analyze in a situation which we have just done. Okay, in the previous situation we can analyze DRS technology. In this one, with constant population model, okay, analyzing DRS technology will be a little bit uh, in this it will not. So basically there'll be some issues, with some population, with constant population growth there'll be some issues. But let's say if your population growth rate is falling across time, then we can still do something with DRS as well. Okay, but with constant population growth there'll be some issues. Okay, and I'll discuss those issues when I'll be talking about this uh, you know this capital transition equation for this particular model. Okay, so let's do that. Okay, so let's Let's see what happens across time. So it's basically the same thing that is happening here also. Initially there is some amount of capital. We can discuss the centralized solution first, and then we'll try and figure out its decentralized wage and rental rate that will make sure that market clear. Okay. So it's everything is the same. The only thing is that now when we are going to talk about steady state, so what do you think in such a scenario, where the population rate is growing? Okay, would you like, I mean, what would you expect? Do you think that aggregate values, let's say aggregate output, aggregate labor, sorry, aggregate capital, that should converge to some steady state? I mean, is that ideal for this economy? I mean, do you think that, so what will be steady state here? So what do you think should be steady? If you really think about this particular economy, okay, uh yeah, so if you just think about this particular economy where people are increasing, in every period, there are some people getting added to the population, and if let's say the aggregate output converges to some steady state, that that really is not a very nice result, because if you really think about it, because every period there is a lot of people to feed, the people to feed are increasing. So in average terms, if you are converging in aggregate terms, in average terms, the consumption is falling, the income is falling. So that's not really something that uh, kind of interesting, right? I mean, you don't want that to happen. Do you agree? Right? Okay, so anyways, I mean, it may or may not happen, that doesn't really matter. The key thing here is this, that the economy where there is no change in the production function, okay, every period the production function is the same, so the technological know-how is absolutely the same in every period. There is CRS technology, labor is growing at the rate and in every period. Okay, so the best that we can hope for is convergence in per capita terms, consumption. So if per capita income converges, per capita capital converges, per capita consumption converges, this is the best that we can hope for in such an economy. Do you agree? Okay, so we'll see if that can happen. Okay, we are hoping that this will happen, but we'll see if that indeed happens or not. Okay, so what I'm going to do is I'm again going to write in aggregate terms that equation of capital transition. It's the same equation, it's still going to work. Kt plus 1 is equal to the leftover capital from the previous period plus the fresh capital that is getting added as investment to the capital stock, okay, which is SFLTKT. Okay, now this is in aggregate terms. Okay, so what I'll do is, I'm just hoping that everything converges in per capita terms. Okay, so what I'm going to do is I'm just going to divide this whole thing by LT. Okay, so let's just do that. Okay, so KT plus 1 by LT is equal to 1 minus delta KT by LT plus S F LT KT by LT. Is that okay? Fine. Now what I'm going to do is I'm going to take the left hand side, okay, and multiply and divide it by LT plus 1. Okay, so just LT plus 1 by LT plus 1. Okay, now this term will be 1 plus n, Okay, this term will be small. So let's call this small kt plus 1. So small kt is basically the per capita capital in time t. Okay, small kt is per capita capital in time t. Okay, and this will be 1 minus delta small kt. Okay, and this will be s. So I can take this lt inside, because it's a crs technology. Okay, so if I just take this 1 by lt inside, I'm going to get sf1 comma small kt, right? Yes or no? Okay, so this is basically in per capita terms, and this is how your per capita capital is changing over time. Okay, and notice that if per capita capital is going to converge, okay, I mean, that's what we are hoping. If it does, if it indeed converges somewhere, okay, then we know that this is basically your per capita income, okay, this term, and it only depends on per capita capital, so that will also converge. That means the per capita savings will also converge. That means the per capita consumption will also converge. Okay, so this is the best that we can hope for in such an economy. Is that okay? Okay, so let's see, if it is indeed true or not. What we are going to do is we'll again consider examples that we have just seen, and of the production functions that we have just seen, and then we'll just analyze the scenario for those production functions. Okay, so let's consider yt equal to lt half kt half. Okay, fine. Okay, now I'm just going to write it in this term, in this way. Okay, so I'm going to get 1 plus n kt plus 1 is equal to 1 minus delta kt plus s times, you put instead of labor you put 1, instead of capital kt you put small kt, so you're going to get s kt half. Is that fine? Okay, any questions? Okay, notice that this is exactly the same equation as you got earlier. If you just see this one, okay, the only difference is that you also have this 1 plus n term to the left, right? Okay, so just look at this. Okay, it's exactly the same term as this. The only difference is that you have 1 plus n on the left. That's it. Okay, now again you can just do the same kind of picture, okay, and figure out if this is converging somewhere. So let me just write kd plus 1 is equal to 1 minus delta upon 1 plus n kt plus s kt half upon 1 plus n. Okay, okay, so if I draw this, again you can take the derivative if you wish and check, the slopes and all. Okay, so again as kd goes to 0, the slope will go to infinity. Okay, so if you just do the derivative here, you'll find that. Okay, and as kd goes to infinity, the slope, so what happens to the slope? It will converge to 1 minus delta upon 1 plus n. Okay, so notice that 1 minus delta upon 1 plus n is also less than 1 because n is positive, and this one was already smaller than 1, so you have divided by something greater than 1, so it is still smaller than 1. Okay, Okay, so if you plot this again, I've drawn a 45-degree line here. Okay, and then I'm just going to plot a curve like this. Again, I know that it will cut this, okay, somewhere. Okay, and again, if you start from here, you'll reach there. Okay, so this is your steady state. Okay, let's call this K star. Okay, and we can solve for K star. Okay, so how do you solve for K star? Again, you do the same thing. So 1 plus n K star. Okay, please note that this is steady state in terms of per capita capital. Okay, so per capita capital is what is becoming the same in every period. Okay, and that also makes sense. It doesn't make sense that aggregate terms in aggregate capital is becoming steady, because of the population growth. It doesn't make any sense at all. Okay, so 1 plus n K star is equal to 1 minus delta K star, okay, plus S K star to the power half. Okay, we just have to solve this. Okay, so let me just take this to the other side. You're going to get n plus delta K star equals S K star half. Okay, and again, you do the same kind of thing. You will get K star equals S by n plus delta square. Okay, so that's the steady state capital per capita. Is this clear? Okay, now once you have this, you can again ask the same question. What savings rate maximizes per capita consumption, okay, in the steady state? So that's your golden rule of capital accumulation. Okay, I mean, at least the good news here is this, that in per capita terms, we have a steady state. Okay, and once we know this, then we know that we have a steady state in terms of per capita income, per capita consumption. Okay, so what is per capita income in the steady state? It is y star, which is s upon n plus delta. Okay, so this is the per capita income in the steady state. Okay, and what is per capita consumption in the steady state? It is so whatever is the per capita income, you consume this much. Okay, so that's your per capita consumption. Again, you can see that the golden rule of capital accumulation is the one that maximizes per capita consumption now. Okay, so instead of maximizing aggregate consumption, you'll be maximizing per capita consumption, because that's what matters. You want across generations everybody to be consuming the same. Are you getting my point? Okay, so across generations everybody, because there is no technological growth, so this is something that you can expect. If there is no knowledge gain, no nothing, the production function is the same. So this is the best that you can hope for, that every generation is enjoying the same level of consumption in per capita terms. And that's where CRS plays a role. Okay, because if there is a constant to scale, even if the population is growing, you can still multiply the production by the same factor, and it is doable, with this kind of technology, with CRS technology. Okay, and you can ensure per capita steady level of per capita consumption across generations for all the people. Is that okay? And the golden rule of capital accumulation is half. Is this clear? Okay, and yeah, so you can also figure out the rental rate, wage rate, using the same technique that we have already done. okay, and you'll get it. Okay, so is this clear to everyone? Any questions? Okay, and you can also do the comparative static. Okay, as you can see that what happens as n goes up, what happens as delta goes up, you know. So what do you mean, what is the interpretation of sg equal to half? So this is the savings rate at which you maximize your consumption per capita. Okay, so I mean basically it has some connection with this. Okay, so you know, like uh, it will depend on this, you know. So if you take some other production function, let's say this one, you know, you will get you know, the savings rate accordingly, you know. So so it depends on, you know, how much important capital is in the production process. So accordingly you would like to save and augment the capital. Okay, so it has some connection with this one. Okay, so of course you know, you can figure that out yourself. You know, you can just do this problem for a general production function, general Cobb Douglas technology, uh, you know, and try and figure out what will be the golden rule of capital accumulation, you know, where the coefficient of capital is alpha. Okay, so you can take that as an exercise. Okay, I mean it's just straightforward. Do the same steps, no difference at all, and you'll get it. Okay, is that fine? Okay, so now let's introduce technological growth. Okay, so what I'm going to do is this. I'm going to consider a production function yt equals f of kt. Well, let me write atlt kt. Okay, so that's the kind of production function that we have. Okay, again we are going to assume CRS technology. Okay, so if you multiply both these by lambda, then the output gets multiplied by lambda. Okay, so here this 80 is, you know, the factor that is affecting, you know, how good the labor is, okay, in every period. So you can say the effectiveness of labor is increasing, okay, in every period. Okay, so you can imagine that now you have, so if let's say it is increasing at a constant rate, you know, then you can have a sequence like this. So you start with a0, okay, and then in every period, 80 plus 1 is 1 plus g times 80. Okay, and lt plus 1, again we can also assume that there is a population growth, 1 plus n times lt. Okay, is that fine? Okay, by the way, before I do this, let me ask some of the questions in this model that they usually ask in the entrances, you know, I mean just to be sure that you have understood all this. Okay, now can you tell me what happens, what is the rate of growth of per capita? So in this model, okay, only the population growth. Okay, what is the rate of growth of per capita output in the steady state across time? Zero. Is that okay? Very good. Now what is the rate of growth of aggregate output in the steady state? What is the rate of growth of aggregate output in the steady state? That's n. Is that okay? Is that clear? Because, you know, this is the per capita output. So if this is per capita output and the population is growing at the rate n, the aggregate output must also be growing at the rate n, because it's the same per capita output that every generation is getting in the steady state. So if it is the same per capita output every generation is getting in the steady state, then aggregate output must be growing at the same rate as the population rate. Okay. So you can be asked questions like these. What is the rate at which the aggregate capital per capita, sorry, what is the rate at which aggregate capital is growing, in the steady state? So if you see aggregate capital, the per capita capital is growing at the rate 0. Okay, but the aggregate capital will be growing at the rate n. Okay, similarly here, what is the rate at which aggregate consumption is growing, okay, in the steady state? So again, you can answer this very simply, because per capita consumption is a fixed number across time in the steady state. So aggregate consumption must be growing at the rate n. Is that clear? So how do you handle this one? Okay, again, it's the same. So now again, we are so basically now here we are talking about technological progress as well. Okay, so we are assuming that technology is growing at the rate g, population is growing at the rate n. Okay, and we want to analyze this situation. Okay, we want to see what happens, what can we expect here, like what will converge. That's the first thing that you should always think about in these models. So don't just write the equation and straight away do it. Just think about what will converge, what can you hope for. So those are the kind of things that you should immediately think about before even writing the equation and just trying to solve it. Okay, so and what do you think, in this model, where people are becoming smarter over time, as there's this factor g coming here. Okay, and labor is growing at the rate n. So do you think that in per capita terms, there'll be convergence? No, right? Okay, there'll be no convergence in per capita terms. Okay, in fact, it's very sad if that happens. Okay, people are getting smarter, so obviously the smarter generations should be enjoying more consumption. Do you agree? So if future generations are smarter, they are entitled to more consumption. Okay, so anyways, what we can do is this, that to actually handle this, we can again first write the capital transition equation. KT plus 1 is equal to the leftover capital from the previous period, plus whatever is a fresh inclusion of capital as investment, which is SF ATLT KT. Okay, fine. Now what I'm going to do is, instead of dividing it by LT, I'll divide it by ATLT. Okay, so ATLT, KT plus 1 upon ATLT. So we can actually hope for convergence in, or convergence of, you cannot call it per capita capital, you can call it per capita effective capital if you wish. Okay, so per capita effective capital. Okay, so because you also including this factor in the denominator, ATLT. Okay, so anyways, okay, so 1 minus delta KT by ATLT plus S. Again, because it's a CRS technology, you can take ATLT inside. Okay, and you're going to get F1 KT by ATLT. Okay, so again, you can just multiply and divide by AT plus 1, LT plus 1, AT plus 1, LT plus 1. Okay, and this is going to be just 1 plus G into 1 plus N into KT plus 1 is equal to, well, just a minute. Okay. So this is AT plus 1 by AT is 1 plus G, LT plus 1 by LT is 1 plus N, kt plus 1 by at plus 1 lt plus 1. Let me call that small kt plus 1. Okay, so basically it's the same thing now. Okay, kt plus s f1 kt. Okay, okay, so this is in terms of the path in terms of per capita effective capital. Okay, so again, if you want, you can just use the same production function, which is yt equals at lt half kt half. Okay, so you have this production function. Okay, so I've just included this at in here. Okay, and what I'm going to get is, for this particular production function, I'm going to get 1 plus g 1 plus n kt plus 1 is equal to 1 minus delta kt, okay, plus s. So you can just put instead of at lt, you can put 1, okay, because the first term is 1 and then next term is actually the same thing. Okay, that's it. Okay, so this is just the same thing. I mean, if you just see what we got in the previous one, it was 1 plus n kt plus 1 and the same term on the right hand side. Now we just have one additional term, 1 plus g there. That's it. Is that okay? Okay, now again, you can solve for the steady state in the same way. Okay, so I'm not plotting the graph now, it's the same graph. Okay, we can straight away solve for the steady state. 1 plus g 1 plus n k star equal to 1 minus delta k star plus s k star half. Okay, and then if you want, you can just open this up. You'll get n plus g plus ng. Okay, so what happens in some textbooks, they just ignore this term. Okay, they ignore this because n is a small rate of population growth, g is also a small rate of technological growth. So if you take their product, it will be like very small. Okay, so if you want, you can ignore it, otherwise you can keep it. Okay, whatever way you like. Okay, so this is k star, okay, equals delta k star. Okay, so I've just canceled the ones. Okay, sorry, minus delta k star. So let me just take that to the other side. Okay, n plus g plus delta plus ng k star equals s k star half. Okay, and then it's just the same thing. Okay, you're gonna get k star equals s upon n plus delta plus g plus ng squared. Is that fine? Okay, so let's stop here for today and I'll see you tomorrow. Okay, yeah.